afternoon, everyone. Welcome. I am Sudheer Kumar Nanduri from IIT Bombay. I'll be presenting my work on automated schedule enrichment from daily progress reports using a bidirectional Neuro-Symbolic AI approach. Before going into the whole topic, I would like to give you a small intuition of what I'm trying to do here. Right now, I'm presenting this work in a ballroom with around 8 chandeliers and absolutely no view outside. But this is also a ballroom named Kerkera Ballroom. So there's a difference in the terminology. First, I mentioned this room with its features, and I call that as an informal definition. We use in our regular parlance, we use different terminologies informally to refer to different spaces or different works. Whereas the formal naming which we give is what the Kerkera Ballroom means. Now, in our whole schedule of this event, we see Kerkera Ballroom and all the events happening there, not the informal things. Whereas when I am talking to my friend, I might be mentioning that informal terminology. So that's where the difference happens. In Indian construction industry, what we see is there are two different sets of people. One set of people sit in the office, they create the baseline schedule from the project scope. They take out the scope, they break it down into work breakdown structure, and then give the precedence, constraints, logic, basically start and end dates for each of the activities. But then there are a set of people who implement this work in the field. They want to do, they work with the people and they update the progress report. That's what is on the right and left side. The right side is the baseline schedule and left side is the daily progress reports. Now these two people are using different terminologies. The baseline schedule uses the contractual terms and the basic drawing-based definitions, whereas the informal terminologies comes up in the daily progress report. Now there is one person who has to sit and understand what these two people are thinking about and talking about, and then update the baseline schedule. That's how you update the schedule in India at least. I'm not sure about the global or European context, but this is where I targeted a solution. Why don't existing methods solve this problem? LLMs already are able to understand what we are talking about, but rule-based systems are good in constraint-based evaluations. And then if you are able to connect them sequentially, you do LLM and then do a rule-based system, it might work, but the problem is once the validation happens in the rule-based system, it doesn't feed back to the neural system, which is the large language model here. So what we came up is with a symbolic reasoning subroutine, which works within the neural loop. At a broader level, a neural loop, the LLM is working to propose what the person informally is referring to. And then there is a symbolic validation happening through knowledge graph. But then this is also a very simple system where you have two parts sequentially connected and then connecting back. Where the change is happening is the knowledge graph, which we kept at the center. This we have added one more layer saying a maturity layer. We evaluate the maturity of the knowledge graph and try to make it work by itself. We are not going to sit and connect every element. So to do that, I'll go into more details about my system architecture. Broadly, there are 3 layers: data preparation, knowledge graph, and then neuro-symbolic matching. At the data preparation layer, initially I started with a basic domain ontology and created a basic knowledge graph. And then I enriched it using the baseline schedule. We have a project and then there is a schedule. From that we took schedule elements and connected it to the knowledge graph. Now after that, we took the daily progress reports from the field and then extracted each individual row of the data, what the person is talking about informally, and then sent both of them together to LLM. That's where the neural layer is coming up. A LLM is looking at the daily progress report, what the person is talking about, and the schedule. Together it is trying to understand what might be the relation, what activity the person is referring to. And then the second part is knowledge graph is going to give us set of constraints where I'll give it to you in more detail, but basically from these constraints, we are going to calculate symbolic validation confidence. So I'm not sure whether you are able to see that, but yeah. So essentially what we are doing is for the neural layer, there's a confidence coming up from the LLMs, and then for the symbolic layer, there's a confidence coming up from the constraint evaluation. Both of these can have some disagreement, but they also have this fused confidence. This fused confidence is the overall confidence whether some element in the daily progress report is matching with the schedule. And from there, we have a set of flowchart where whether we want to update the knowledge graph or whether we want to just go back and update the LLM to create a new proposal. This is the overall architecture. Let me go into slightly more detail. At the data parsing level, the initial data preparation level, we have two steps. One is the knowledge graph initialization, which I already mentioned to you about. The DPR parsing is semi-automated, where we have sent the DPR, that is the set of Excel files, to an LLM to generate a parser and then let it extract the data. But we also had to loop it back to verify whether it is working good or not. Then the second part, the most important part is this. Once a daily progress report, the progress report entry comes up from the neural proposal layer, it goes into symbolic validation, it gets verified, and both of them go into the disagreement check, and this becomes an iterative refinement. How do we get it? Using this adaptive knowledge graph maturity score, we evaluate vocabularies and triples from the knowledge graph. We count them basically, and see this 210,000 is not a direct data entry as such. We are looking at how many progress reports we have taken. Here in our case, we took 1,000 progress reports, and then we evaluated these numbers to be 210,000. But basically, we are looking at how big the knowledge graph is. From that, we are calculating this maturity score and deciding if the maturity is less. That means the knowledge graph is not confident on what we are speaking about. So it will lean more into the LLM-based evaluation. But once the knowledge graph is more filled up, it is more mature, now the knowledge graph is confident what we are talking about. So then it leans towards the symbolic layer. And this overall system we have validated on one project site, but it has 3 different buildings, and we collected 173 DPR files and 1,000 activities. And then we compared it against 3 baselines: basic traditional NLP, pure symbolic, and pure neural. We also had 4 strictness levels, whether coverage, whether it is connecting any element or is it connecting any activity, building, and strict UIDs. This is a broader result. We had 82.5 of the confidence percentage, and then 88% entity compression. The major errors are coming up from cross-building errors. That means the same activity is happening between different buildings. Our system is not able to correctly differentiate them. And then we did the ablation studies and found KG validation, vocabulary learning, iterative refinement. These are the core components of our whole system, and they are proving to be valuable. And this is the overall knowledge graph growth which we have shown. Initially, we started with 86 nodes, and then it went up to 34,600 at the initial stage, and then 39,620 at the DPR stage. And yeah.
Thanks. Yeah. you could have shown, if you have any conclusions or something, you can show as well.
So basically,
yes,
we have found that there's a synergy we can establish between the LLMs and knowledge graphs, which we came up with saying maturity score. That's the thing.
Thank you. Thank you very much.